The Fumehoods-Acela fume hood is a state-of-the-art high-performance low-flow fume hood designed in strict compliance with the following international standard. For fume hood performance requirements as defined in the American Standard ASHRAE 110-1995. For fume hood performance requirements as defined in the Harmonized European Standard EN 14175. Key features include safe operations at 0.3 meters per second or 60 feet per minute face velocity while maintaining excellent containment per ASHRAE 110 and EN 14175. High energy efficiency with up to 62% reduction in air volume without compromising safety. Superior laminar topography and perfect protection perimeter designed to ensure highest levels of containment. Excellent aesthetics and ergonomic design create a more comfortable work environment for the user. Convenient access to plumbing connections and easy-to-clean parts which are critical for the long-term well-being of the hood. A wide range of options and accessories to suit the user's application. Operator safety is the fundamental goal in fume hood and enclosure design. ESCO Fumehoods-Acela fume hoods exceed the required standards to ensure that operator safety is never compromised. This section highlights the significant safety features designed into the Fumehoods-Acela fume hoods. ESCO Fumehoods-Acela fume hoods are tested based on the ASHRAE 110-1995 and EN 14175-2003 standards. For ASHRAE 110, the major tests include smoke pattern tests, face velocity test, and tracer gas containment tests using sulfur hexafluoride or SF6 gas. For EN 14175, testing procedures include inner grid tests, outer grid tests, and robustness tests. Rigorous testing is done on all Fumehoods-Acela fume hoods with 1 in 10 standard fume hoods being tested before dispatch. ESCO is devoted to operator safety and has few rivals with the necessary expertise and equipment to do in-house testing. Fumehoods-Acela hoods are independently tested by third-party laboratories in both the US and in Germany. ESCO Fumehoods-Acela fume hoods are tested and certified to the EN 14175 Part 3 and ASHRAE 110 standards. Fumehoods-Acela fume hoods are available with an optional Sentinel XL digital display airflow alarm system. The Sentinel XL controller accurately monitors face velocity in real time and alarms when face velocity decreases to unsafe levels. In the event of unsafe conditions, the Sentinel XL provides both audible and visual alarms to prompt the user to stop work and to contact the relevant service authorities. When working in a fume hood, remember to keep the sash closed as possible. Hood airflow is generally stronger when the sash is lowered. In order to encourage users to work at safe positions, ESCO Fumehoods-Acela fume hoods have built-in sash stops that limit sash movement beyond 457 millimeters or 18 inches opening. The position of the maximum allowable working height is clearly indicated on the hood. For loading and unloading purposes, the user may raise the sash above the operating height by releasing the sash stop. Notice how the Fumehoods-Acela fume hood sash gently creeps back down to its operating height even when the user unintentionally forgets to lower it to the required position. A key lock system is installed to allow safety officers to restrict the use of the fume hood. It also allows laboratory managers to override the creep down mechanism of the sash to allow for loading and unloading of bulky items. Fumehoods-Acela fume hood sashes are constructed from laminated tempered glass. Users can work with peace of mind and not worry about glass pieces splattering towards them should there be an explosion within the hood. In the event of an explosion within the work zone, the fluorescent light casing automatically acts as a pressure relief, therefore maximizing operator safety. The following animation illustrates how the loosely secured casing performs this safety function. All Fumehoods-Acela fume hoods are coated with ESCO isocide antimicrobial coating to protect against surface contamination and inhibit bacterial growth. With isocide, 99.9% of bacteria on the coated surface is eliminated within 24 hours of exposure. The need and desire to conserve energy, use sustainable materials, and protect the environment are very compelling. In addition to being noble from an environmental aspect, this strategy can also contribute to cost containment. As a dynamic and progressive company, ESCO is devoted to these goals. The Fumehoods-Acela fume hood is designed with energy savings in mind. It can operate at a lower face velocity than most conventional fume hoods while achieving superior performance and containment. By lowering the operating face velocity, up to 62% reduction in exhaust volume is achieved, which reduces operating costs by up to $5,000 per year. This diagram illustrates the cost savings achieved when operating a high-performance, low-flow fume hood like the Fumehoods-Acela. Cost is saved from having smaller ventilation systems for both makeup and extraction air, reduced electrical energy consumptions from running these ventilation systems, reduced wastage of heated or cooled air out to the environment. Laminar topography on Fumehoods-Acela fume hoods was developed with computational fluid dynamics in ESCO's Research and Development Center. Precisely tuned aerodynamics is the fundamental design strategy that gives rise for the perfect protection perimeter, outstanding operator safety, and high energy efficiency. Seemingly insignificant components have been rigorously thought out. The sash handle is aerodynamically designed with air slots to gently guide air into the hood, eliminating possible buildup of turbulent eddies in that critical zone behind the sash. Acela shaping vanes at the sidewall increase airflow sweep on the critical area parallel to the sidewalls. This enhances containment, especially with pedestrian traffic in front of the hood. There are a total of 5 different baffles placed at different pitched angles to draw most containments back in a single pass displacement of air. The bottom baffle is perforated to improve laminar flow into the back of the hood and out through the exhaust plenum. An airfoil is mounted on the work surface to provide maximum airflow sweep on the critical boundary layer near to the work surface to reduce turbulence and eliminate backflow. All these elements ensure that airflow into the fume hood is smooth and without turbulence. A tapered exhaust collar transition exhausts air quietly and enhances face velocity uniformity. With a more uniform flow, containment of the hood is enhanced, resulting in more predictable operator safety. The ESCO Fumehoods-Acela fume hood has a neutral color scheme and futuristic design that makes the laboratory work environment pleasant. In addition to having a brightly lit work zone, Fumehoods-Acela fume hoods incorporate several ergonomically designed features to enhance the working comfort of the operator. Fumehoods-Acela fume hoods are designed with a high sightline of 1.8 meters or 71 inches, creating a bright and airy workspace. The 5-degree pitch of the face enhances operator comfort, improves reach into the work zone, and contributes to good overall aesthetics of the hood. The large arbor sprockets and chain drive make the up and down sash movement quiet and effortless. The chain and sprocket system has increased durability compared to conventional sash mechanisms. In the event of a failure in the primary chain, a redundant dual chain drive causes the sash to tilt and therefore locks in position. ESCO Fumehoods-Acela fume hoods are designed for easy maintenance. The baffle system is removable from the fume hood to allow effortless cleaning.